If you're here, you're probably like me. You want to get smart. That's right. We all do. And that's kind of what we try to do here. Forget having to read, 1,000 pages. We dive deep into the information, pull out the good stuff, and, give it to you straight. But today we are doing something a bit different, something a little outside the box, but I think it's right in line with our mission here. So we're going to explore this novella called The Z Point. And we're not just looking at it as like, oh, a cool story, but as this surprisingly really well-informed piece of fiction. The author takes real-world science, takes it to some pretty interesting places.
Yeah, for sure. Fiction can be a really awesome shortcut to understanding, some of these really complex ideas. It makes the science more tangible, and it definitely sparks that curiosity in ways that, like, a dry research paper never could. I think The Z Point is a really great example of that.
It really is. Just pulls you right in. Right away, you've got this main character, Tony Ashida. He's a cybersecurity whiz. And he's just reeling from this loss of his friend. His friend was on this flight 714, that just vanished, crashed mysteriously. And the official story, super simple. Mechanical failure, case closed. But Tony, he's not buying it. He digs into all this data from the wreckage, finds patterns in the case. That's his whole thing, right? And he stumbles on these thermal signatures, these heat readings that just don't make sense, not for a normal plane crash anyway. And the novella has this really awesome vibe, kind of unsettling, like something's off, almost Philip K. Dick-ish, where you get the feeling that there's just way more going on under the surface.
Yeah, totally. That sense of unease, it's really important. I mean, for someone like Tony, his whole life is about finding these hidden threats, these patterns in this sea of digital noise. So when he sees these impossible, thermal signatures in the physical data, in the actual wreckage, that's a huge red flag for him. It's like flashing lights and sirens going off. And it sets up this great central question. Do we just take the easy answer, the neat official explanation? Or is there something weirder going on here? Something that data is trying to tell us?
Okay, so let's get into that weirdness.
Yeah.
So Tony's not a scientist, right? He's a cybersecurity guy. So how does his background, help him uncover this big mystery? It's got to be more than just a convenient plot device, right?
Yeah. Oh, absolutely. What's so clever here is the author actually uses Tony's main skill, superpower, which is pattern recognition. Tony, he's used to digging through tons and tons of digital information, seemingly random data to find those little anomalies. He connects the dots where everyone else just sees noise. So when he's looking at the thermal data from Flight 714, his brain's already wired to look for the unexpected.
And the light bulb moment, the aha moment comes when these thermal signatures, these random heat readings, they suddenly form this perfect equilateral triangle. It's just too perfect. In a catastrophic mechanical failure, you'd expect chaos, random stuff. Not this super precise geometry.
Exactly. You nailed it. That order, that shape, in the middle of what should be complete and utter chaos, it's the author's way of shouting, hey, something unnatural happened here. It just throws the whole mechanical failure theory right out the window. And that's where the novella introduces its big idea, its scientific backbone, exotic vacuum objects, or EVOs for short.
So EVOs. These aren't just some made-up sci-fi gizmos, right? This comes from actual science. Where does the novella draw inspiration from?
This is where things get really, really cool. The novella takes inspiration from the work of this guy, Ken Shoulders, a real physicist who started doing this research back in the mid to late 1980s. Shoulders was looking into these bizarre phenomena that he called, get this, electron validum, or EV, which he later changed to, you guessed it, exotic vacuum objects, or EVOs.
So we're not dealing with pure fantasy here. There was some serious scientific research into something that's basically got the same name, the same concept. That kind of hints at a huge point, doesn't it?
Yeah.
Sometimes the biggest breakthroughs come from outside the mainstream.
Definitely. Shoulders, he was all about experimentation, hands-on. He was looking at these clusters of like condensed charge, but he was doing it in this completely unique way. And it's interesting, during the 80s, he actually teamed up with Hal Puthoff at Jupiter Technologies. They were focusing on this condensed electron technology that basically formed the foundation of his whole EVO research program. And he stuck with it too. It was his passion for decades.
So how does the Z Point, how does it portray these EVOs? They take this real science, even if it was, kind of fringe, as a jumping off point, right? What do they do with it?
Well, in the novella, EVOs are these self-organizing plasma structures, but with this crazy ability, right? They interact with the quantum vacuum. This isn't your everyday plasma. It's like they can tap into this deeper level of reality. The book describes them as these really bright points of light, and they often cause these wild electromagnetic effects. And get this, they can actually warp space-time.
Space-time warping, that's some serious stuff. The novella doesn't mess around.
Not at all. And the coolest thing is, the author isn't just making this up out of thin air, right? It's all based on real observations of these strange things that happen in plasma discharges. You can find this stuff in the scientific literature. There are links, although still debated, of course, to some cutting-edge research in vacuum polarization and quantum field theory. It's like the novella's hinting at this huge idea from quantum physics that empty space isn't actually empty at all.
Which brings us to zero-point energy and the quantum vacuum itself. This is another big scientific idea that the novella uses, isn't it?
Oh, for sure. The things that EVOs can supposedly do in the novella, they're all tied to this idea of zero-point energy. So in real-world quantum physics, zero-point energy is basically the lowest possible energy state that something can have, even in a perfect vacuum at absolute zero. It's like even when everything's supposed to be still, there's this underlying energy, this buzz going on in what we think of as empty space, the quantum vacuum.
And the amount of energy in those fluctuations, it's supposed to be absolutely enormous, right? Even if it's all theoretical, it makes you wonder, doesn't it?
Yeah.
What if we could tap into that? The potential is just mind-blowing.
It is. It really is. And this is where the Z Point takes this idea and runs with it. In the story, they figure out how to harness zero-point energy by creating and controlling these EVOs right at that boundary where plasma meets the vacuum. The EVOs act like this conduit that channels this limitless source of energy.
So they're basically saying, hey, clean energy, problem solved, just create some EVOs and boom, no more fossil fuel.
Pretty much.
So
The novella proposes that if we could control these EVOs, we could have all the clean energy we could ever need, no more pollution, no more worrying about running out of fuel. It even suggests that we could have this incredibly dense portable power source. And they even hint at things like, get this, wormholes.
Wormholes, powered by the energy of empty space.
That's
a big jump for a novella. So how does plasma science and this electric universe theory that they mention, how does all that fit in?
This is where things get even more interesting. The novella starts mixing in these less mainstream ideas. So plasma, it's often called the fourth state of matter. It's like a gas where the atoms have lost some of their electrons, right?
Yeah.
So you've got these charged particles floating around. Now, electric universe theory. What's the gist of that from what you've read?
Well, I think the basic idea is that electromagnetic forces are actually way more important in the universe than most physicists currently think. Like, they're the driving force behind a lot of the stuff we see happening out there, not just gravity.
Exactly. And a big part of electric universe theory is this idea of scalable plasma physics. What they're saying is the way plasma behaves in a lab, that same behavior should apply at much larger scales, even on a cosmic level. So the Z Point uses this idea to suggest that understanding how plasma works is like the key to unlocking zero-point energy, to creating these crazy technologies like wormholes. It's like by controlling plasma through these EVOs, they can do stuff that seems impossible according to our current understanding of physics.
And the book introduces this whole element of these plasma researchers, these scientists who've kind of been pushed to the sidelines, right? Tony ends up putting their work together, doesn't he?
Yeah, it's a really cool part of the story. The author creates this whole narrative where scientists who are exploring these electric universe ideas, these weird properties of plasma, they're basically ignored or even shut down by the scientific establishment. So Tony's big breakthrough, it doesn't just come from his own insights, but also from recognizing the value in all this scattered, dismissed work. He takes these fragments and combines them with what he's learned from the Flight 714 data.
Now, there's this thing called the Schwinger limit that they talk about a lot when they're talking about wormholes. What is that exactly, and how does the novella use that?
Yeah.
So the Schwinger limit, it's like some kind of a breaking point for space itself, right? Like if you have too much electricity, space just can't handle it.
That's a pretty good way to think about it. The Schwinger limit, it's this theoretical point where an electric field gets so strong that empty space itself becomes unstable. It starts spontaneously creating particles, pairs of electrons and positrons out of thin air. To reach this limit normally, you'd need an insane amount of energy, like more than we can even imagine creating right now.
So how does the novella get around this energy problem? How do they create wormholes if it takes so much energy just to make space break down?
Well, that's where EVOs come in. That's their big trick. The novella says that by controlling EVOs in just the right way, you can locally exceed the Schwinger limit without needing all that crazy energy that you'd normally need. It's like they create a little bubble where space breaks down, but in a controlled way. And that lets them create these stable wormholes, these tunnels through space-time. There's also this interesting bit where the government and the story, they're trying to do this too, but they can't quite stabilize things at the Schwinger limit. And the book hints that this instability was a factor in why that teleportation experiment on Flight 714 went so horribly wrong.
Which brings us to the teleportation itself. The whole thing's based on creating these pairs of wormholes that are controlled by EVOs, right?
Exactly. The novella's version of teleportation is basically this. They make this temporary tunnel, this wormhole, between 2 points, and they use EVOs to hold it open and keep it stable. It's like building a bridge out of space-time. But, like we just talked about, the government's experiments, they had all these problems with instability, which shows just how dangerous this technology could be if it's not handled perfectly. And that's what Tony discovers about Flight 714. It wasn't a mechanical failure, but a failed teleportation. The thermal anomalies he found, those were signs that EVOs formed, but then went out of control, and, well, you can imagine what happened after that.
So we've gone through all this cool science behind the Z-point, but what about the story itself? Is it actually a good read, like aside from the science?
The Z-point is amazing because it manages to blend a great mystery, this whole thing about what happened to Flight 714 and Tony's search for answers, with real science. And it does it without getting bogged down in a bunch of technical jargon. It gives you just enough of the science to make the story believable, to make you think, wow, maybe this could actually work.
So it manages to be both entertaining and educational, without feeling like a textbook.
Exactly. The mystery itself keeps you hooked, and you learn about all this fascinating science about EVOs and zero-point energy along the way. It's like you're right there with Tony, figuring things out as he goes. It makes you want to learn more about this stuff, even the things that most scientists don't really take seriously yet, like plasma physics and the electric universe. Yeah. It gets you thinking, what if some of this crazy stuff is actually true?
So it's a good sci-fi thriller and a thought-provoking exploration of some pretty mind-bending physics.
Absolutely. The Z-point isn't just a fun read, it stays with you. It makes you think about the potential of science, what reality is really all about, and even what could happen if technology advances too quickly. And it does all that while telling a great story. It takes these really abstract, really complex scientific ideas and makes them feel real, almost within reach.
So, to sum it all up, the Z-point isn't just some escapist fantasy. It's a novella that uses fictional elements to explore real-world science, giving you this really thrilling and stimulating experience as a reader. It takes inspiration from actual scientific research and theories, even if they're not mainstream, and weaves them into a mystery that you just can't put down.
Exactly. It pushes you to think about the real science behind the fiction, to consider how these crazy ideas might actually lead to things that we haven't even thought of yet.
Which brings us to our final thought for you. Thinking about how the Z-point blends real and fictional science, what other scientific ideas that are out there that maybe people dismiss, what if those ideas turn out to have huge potential? Maybe it's worth taking some time to dig a little deeper into some of the things we've talked about today. Ken Shoulders and his work, the electric universe theory, zero-point energy. You never know what you might find when you start looking beyond the boundaries of conventional science. Thanks for taking this deep dive with us.